apply what we just learned in example 1 to example 2. They've given us a graph, and they're telling us Tony's driving from Dallas, Texas to Atlanta, Georgia at 3 o'clock p.m. He's 180 miles from Dallas, and at 5:30, we're an hour and a half later, he is 330 miles from Dallas. Graph the line that represents Tony's distance from Dallas at a given time, and then we are to find and interpret the slope of the line. Now, finding part is usually not a problem for algebra students or geometry students, since that's what we're talking about. But interpreting is often the case very difficult. So what we're going to do, let's just stick with the math. We're going to let the numbers tell us the story, okay? So notice that we have 2 points that are on this line. I would normally do rise over run, but because that second point is not at a grid intersection, I do not know precisely where that number is, and so I'm going to stick with the formula, okay, just to be sure that I'm doing a good job and I'm calculating correctly, okay? So let's take a look. We got y2. I'm going to do that top point starting with the 330. That's the y of that top point where he's the furthest away, minus 180. And then I'm going to go back to the 5.5 minus 3. Okay, so we just need to do a little bit of math. If you will just take out your calculators, and you probably figured out that's 150 over 2.5. And then go ahead and divide that, and then we get the number 60. 60 has a meaning. 60 as a slope indicates a rate of change. Slope is a synonym for rate of change. In this particular case, the numerator, your rise, according to this graph, is distance in miles. Okay, so I'm going to write that out. And then your run is your time in hours. So as you look at your units, the numerator is miles, the denominator is hours. So that 60 can be interpreted as his speed, because his average speed is 60 miles per hour, is how we can interpret that. Okay, and the graph told me that information. I didn't just invent it all of a sudden. It was on the graph. All the information I needed was on the graph. All right, so what you're going to do is you're going to go ahead and use that graph above to estimate how far Tony will have traveled by 6:30 p.m. So it's, what time is it now? 5:30, so it's an hour later. If his average speed stays the same, how far out will he be an hour from now? Okay, so give it your best shot. And if you have any questions, write those down. We'll check them tomorrow.